All right, so let's look at some questions from the Lesson 10 problem set. Lesson 10 is sort of more of the same from Lesson 8 and Lesson 9. It's still about setting up algebraic equations with variables in them, using the properties of equality to solve them. But in Lesson 8 and Lesson 9, the topics that we build the equations from are things like, oh, so-and-so is this much older than so-and-so. Set up an equation based on that. Or there's this many tokens in this machine and twice as many tokens in that machine. In this lesson, it's all about geometric diagrams with angle measurements in them. So it looks like a geometry lesson, but it's really not. It's still about algebra, just our topics of our equations are these geometric diagrams. So you really only need to remember a couple facts. Angles that are perpendicular to each other, or not angles are perpendicular to each other, angles formed by lines that are perpendicular to each other, or in other words, they look like they're hitting each other straight on like this, are usually indicated by this little box like this. Those are called right angles, and their angle measurements are always 90 degrees. And any smaller angles that are made up of that make up the interior of this 90-degree angles, well, their angle measurement combined, the sum of their angle measures must be 90 degrees. And then if you have this situation here where you have a straight line, and then you have angles that all rest at a point on that line and span the distance from that line back to the line. So when I say the line, I'm talking about this line along points Q and T. Then this is sort of like two 90-degree angles right next to each other. And so these always add up to 180. The measures of all these angles that rest on this line must add up to 180 degrees. And then the last one I guess you also should know is that if you have angles that surround a single point and all these lines intersecting at this singular point here, well, then you're essentially going all the way around in a circle, or you could think of it as two of these straight line situations. And so these are 360 degrees. And so almost every equation that we make in Lesson 10 is going to be adding up some angle measurements, and the total is almost always going to be either 90, 180, or 360. That's pretty much how all these diagrams work. So let's look at number 1. I know this paper says PS8, but we're doing PS10. This marker's getting a little dry. I'll grab a different one. Let's use red. So also for all these assignments, or for this problem set anyway, you can ignore this in a complete sentence, describe the angle relationships, blah, blah stuff. I care about you being able to set up an equation based on the diagram, define your variable as the measure of one of the angles, find the measure of that angle, and solve the equation. So here we have angle DAF, and in its interior I see this smaller angle marked with X, and that's angle DAE, and its measure is X degrees. That's what this X is saying, is that however many degrees this angle is, it's X degrees. And so we're going to define our variable as that. I'm going to say that X equals the degree measure, and we write a little m before the angle symbol. That means that we're talking about the measure of the angle, not the angle of itself, which is a little bit different. Think of it as like you're a person, but you are like 5 feet tall, or however tall you are. The angle is an object, but it has a measure that tells you how large the angle is. So X will equal the measure of angle DAE. And now, since this angle DAF is a 90-degree angle, then I know that the degree measure of this angle plus the degree measure of this angle has to equal 90 degrees. So X plus, angle EAF has measure 65 degrees. So X plus 65 has to equal 90. At this point, I hope you're getting really good at being able to solve a very simple equation like that, so I'm certainly not going to solve that for you. Number 2, we're told that angles QPR and angles TPS both have degree measure F. And then this bigger angle in the middle that's also resting on the line QT is angle RPS, and it has degree measure 154. So these 3 angles, QPR, RPS, and TPS, they all have to add up to 180. So first we're going to define our variable as F for the degree measure of, let's use QPR. We don't have to say that it's also the measure of the other one. That's not important. So it's the degree measure of angle QPR. And then, based on the diagram, I know that F plus 154 plus F has to equal 180 degrees. So F plus 154 plus F equals 180. And so I want you to be able to solve that one. Just combine your F's, get 2F, subtract 154 from both sides. You can handle it from there. All right, let's look at number 3. I see angles on a line again, this line BG. So all these angles that rest on this line and intersect at the same point, their degree measures have to add up to 180 degrees. So that means I should be able to set an equation that says 12 plus 3x plus 103 plus 2x plus 10 equals 180. And that's exactly what I'm going to do. But first, there's not really a good way for me to define my variable in this case, because the variable x doesn't really stand for one single angles measure like f did here and like x did here. So what I'm going to do is I'm going to define my variable x, and I'm going to define it in terms of this angle that it sits within, angle DQC. If angle DQC is 2x, well then that means that x must be half of its degree measure. So x will stand for 1/2 of the degree measure of angle DQC. Honestly, that's a little confusing and difficult. Oh, I realize I'm off the screen right now, sorry. So if you didn't even define your variable on this one and you just set up the equation and solve it, I'd probably be okay with that. So let's go back to the diagram. It's 10 plus 2x. So 10 plus 2x plus 103 plus 3x. Oh, geez, I'm off the screen this whole time. 10 plus 2x plus 103 plus 3x plus 12. And that's all got to equal 180. And, I'll go ahead and solve this one for you. So 2x plus 3x is 5x. And 10 plus 103 plus 12, 103 and 12, that makes 115, plus the 10, that's 125. Notice how I'm keeping my equal signs straight, right? I'm writing my left side expressions as they get smaller. I'm writing them closer to the right side so I can keep it really nice and straight. And now I'm going to subtract 125 from both sides. Oops, I don't know why I wrote 125 here. Sorry. If you're just blindly copying, I hope that you noticed that I made that mistake. So I'm going to subtract 125 from both sides, and I get 5x equals 50 would get me to 175 from 125. So I need 5 more, so this is going to be 55. And so I divide by 5 on both sides, and I get x equals 11. But I'm not done, because that just tells me that the variable x equals 11. I still have to use that variable to find the degree measures of all these unknown angles. I have to use that x to find the measure of DQC and the measure of EQF. So if the measure of angle DAC equals 2x, well, that's 2 times 11, which equals 22. And then the measure of angle EQF equals 3x. Well, that's 3 times 11, which equals 33 degrees. These are, I gotta put our little degree symbols on there since we're talking about angle measures. All right, let's maybe look at one of the ones from 4, 5, 6, or 5 and 6. Let's see here. Number 6 looks kind of challenging, so I'm going to go over that one for you, and then I think I'm done. I'm going to adjust this thing a little bit, see if we can move this down. I think that's a little bit better. So, number 6. It's this one here. It has all these points around, all these angles centered around the point A. And we have x here, 3 y's. We have to use everything we know about angles to make this relatively easy. So I'm looking at the fact that line KG and then line, actually no, I don't think, is that supposed to be a line? It's kind of hard to tell. I don't think JF is supposed to be a straight line. It kind of looks like J is off at sort of its own angle separately from F. So I'm not going to assume that the points J and F make a straight line through point A. So I can still solve for the measures of angle X here. And then I do see that KG makes a straight line and EF makes a straight line. And because those two straight lines intersect at A, that makes angle KAF a vertical angle to angle EAG. And what that will do for me is once I've figured out these two angles here, the ones marked as X degrees, then I'll know what the measures of these 3 y's have to add up to, because these 3 y's have to be equal to these 2 x's here. Okay, so let's do it. I'm going to handle the part with the x's first. So I'm going to write in the box here that says 5, just because it's easier for you to see on the screen based on where my screen's pointing. But know that this is question number 6. I have, within angle EAD, I know that that's a 90-degree angle because I see the box marking angle FAD as a 90-degree angle. And so that means that angle EAD must also be a 90-degree angle. So I can set an equation that says x plus 24 has to equal 90. And so that means that 2x plus 24 equals 90. And I subtract 24 from both sides. And I get 2x equals 66. And I divide by 2 on both sides. And I get x equals 33. So that tells me that the measure of angle EAF and the measure of angle F, I'm going to go ahead and say that the other way, the angle GAF, those both equal 33 degrees. And now let's go back to what I was saying before about vertical angles. I'm going to outline them in red so you can see them very easily. This line from point E to F and beyond. That's a straight line. And then this line from through points K and G, they're a straight line. And when two lines intersect at a point, the angles that are created on, it's hard to describe, but on opposite sides of each other, if you think of this area over here that I'm going to kind of shade as being opposite of this area, those are called vertical angles, and we know that they have the same degree measure. So what we can use is the fact that over here, these two angles combined, since they were both 33 degrees that we just figured out, well, that means this whole thing must be 66. I just did 33 plus 33 real quick. So this whole area over here is 66. That means that this whole area over here, the degree measure of angle KAF, must also be 66 degrees. So we can make a new equation over here to solve for those y's. We can say y plus y plus y equals 66. Or 3y equals 66. And we divide by 3 on both sides. And we get y equals 22 degrees. And so now we can write out that the measure of angle KAJ equals 22 degrees. You know what? Now that I see that it's 22 degrees, I'm really glad that I did not assume that the line JF was straight. Because if it were, then that would have made angle KAJ have the same measurement as GAF. And we see that that's not true. One of these has 22 and one of these has 33. So never assume something's straight unless you can really see that it's straight. I don't know. It's hard to give you good advice on that. I was able to just catch it, I suppose. All right, so measure of angle KAJ is 22 degrees. Sorry, I'm moving stuff around so much right now. And the measure of angle JAH will also be 22 degrees, and the measure of angle HAF is also 22 degrees. So let's see here. Measure of angle HAF is 22 degrees. Notice they all have A in the middle because they're all centered around that point A. And then what's the other one I got to do? JAH. Measure of angle JAH equals 22 degrees. All right, I think I'm going to leave the rest of everything else for you to do without my help.